So hello everyone and welcome to the Math Heist. Today we are gathered here to solve this problem from algebra, and the problem statement is like this. We have two equations in x and y, and then we have to solve for the largest possible value of x which satisfies these equations, and we can represent this largest possible as this form, and then we have to compute this sum a plus b. So for this problem I am going to use two different approaches. One will be a linear and a Batchier one, which involves only algebra, and the other will involve trigonometry, which is a quite a clean solution. So let's start with the uglier one, which involves pure algebra, algebra. Yeah. So for this, we just substitute y is equal to under root of 1 minus x square from the first equation. And why did I not substitute x? Because in the second equation, we have more x stuff here. So I would like to avoid all that. So if we substitute this in the second equation, we get 4x into 1 minus x squared is equal to 1 upon 2x square minus 1. I am taking the 2x square minus 1 to the RHS. So let's just square it. 16x squared into 1 minus x square is equal to 1 upon 2x square minus 1 whole square. Now let's just let this x square as a because it's everywhere. So this equation becomes 16a into 1 minus a is equal to 1 upon 2a minus 1 whole square, which is 1 upon 4a square minus 4a plus 1, and we can take up 4a common. It becomes like this. So observe that we have 4a into a minus 1 here and 4 into 1 minus a here. So probably I can substitute this 4a into a minus 1 as some t. So this expression will become minus 4t, and this will become t plus 1, and then we can take it there and form a quadratic equation. T is equal to 1 minus 4t squared minus 4t minus 1 is equal to 0. On multiplying with t, we have 4t squared plus 4t plus 1 is equal to 0, which means that t is simply minus half, since this will become 2t plus 1 whole square. So we have the value for t. Now let's substitute for solving for a. So we have 4 into a minus 1 as minus half. So we solve for a from here. 8a into a minus 1 plus 1 is equal to 0. 8a squared minus 8a plus 1 is equal to 0. Or it can be written as 8 plus minus 64 minus 32 upon 16, which is 8 plus minus 4 root 2 over 16. And since we want to solve for the maximum possible value for x, I will just neglect the minus term and I will take a as, we can cancel out 1 4, 2 plus root 2 by 4. So I have solved for a, and in our original problem I had let x square as a. So the largest possible value of x is simply 2 plus root 2 under root by 2. So the answer can be like, we can compare it with this. So we have a is equal to b is equal to 2, and our answer is simply 4. Okay, that was cool. But now I will like to discuss the second approach, which is the trigonometric one. Method 2, trigonometry. So we simply substitute x as cos theta and y as sin theta, because this is a parametric form of this circle. So we let x as cos theta and y as sine theta. And why exactly did I not replace x with sine theta and y with cos theta? That's because in our second equation we have this expression 2x square minus 1, and we know that 2 into cos square theta minus 1 is simply cos of 2 theta. So that's the reason. So if we substitute this in the second equation, we have 4 cos theta into sine theta into 2 cos square theta minus 1 is equal to 1. And we know that sine 2 theta is equal to 2 sine theta cos theta, and also 2 cos square theta minus 1 is equal to cos of 2 theta. So using these two, we can write this as 2 sine 2 theta into cos 2 theta is equal to 1, and this again becomes sine of 4 theta is equal to 1. And also note that here I am considering only the principal values in the first quadrant from 0 to pi. So simply I will take theta as pi by 8, because this is equal to sine pi by 2. So we have found x, which was cos theta, as cos of pi by 8. Now we just need to solve this, which can be easily solved by this equation, as we know the value of cos of pi by 4, so which is 1 by root 2. So we put theta as pi by 8 in this identity. So we have 2 into cos square of pi by 8 minus 1 as cos of pi by 4, which is 1 over root 2. So from here we can solve for cos square pi by 8, which is 1 by root 2 plus 1 over 2, which is 1 plus root 2 over 2 root 2, which can be rationalized. We have 2 plus root 2 over 4. So from here we can simply solve for x, which is cos of pi by 8, which is half into 2 plus root 2, like we got in our approach 1. So our final answer is simply 4. I hope you like both the approaches. Do like, share and subscribe. Thank you.